This micro-credential deals with troubleshooting methods and consists of 5 targeted skills. This targeted skill deals with the top-down approach to troubleshooting. The top-down approach is one of 3 approaches to troubleshooting using the Open Systems Interconnection, or OSI model. With the top-down approach, the technician starts in the application layer and works down the layers to identify the problem. The domain name service, DNS, is a function of the application layer of the OSI model. It is used to map domain names to Internet Protocol or IP addresses. DNS makes it easier for users to navigate the Internet because names are easier to remember than IP addresses. One of the problems that can occur with DNS is for the user to mistype the domain name. The technician should double-check the typed Universal Resource Locator, URL, to rule out this problem. Another problem that can occur with DNS is that the DNS server can't be contacted. This problem gives the same error message to a user, but needs to be diagnosed differently. The technician will need to check which DNS servers are configured, as well as whether they can resolve names and can be contacted. To check the configuration, a technician should open a command prompt and use the ipconfig/all command. Network documentation can be referenced to confirm whether or not the information is correct. To check whether or not the DNS server is functioning properly, the technician can use the nslookup command followed by a domain name to see if it will respond and resolve the name. If the server fails to respond, the technician should confirm that he or she can access the server by pinging its IP address. Technicians can confirm DNS server problems by substituting a public DNS server for the one that is currently configured. This can be done through the local area connection properties of the affected device. Sometimes a problem might occur with the application itself. To resolve this problem, a technician can try and open a website or access a network resource using a similar program. For example, if a web browser has problems displaying content or accessing a specific website, using a different browser can confirm whether the problem is with the website or the original browser. Layer 6, the presentation layer, is responsible for a common data format. A website not displaying correctly or a video not playing are types of Layer 6 problems. Plugins and extensions are used to add capabilities to applications and sometimes can correct these problems. Layer 6 is also responsible for encryption and decryption. Websites use Transport Layer Security, TLS, and Secure Sockets Layer, SSL, to prevent eavesdropping and secure information as it travels across the Internet. Invalid and outdated certificates can prevent users from accessing those websites. These errors can also indicate a man-in-the-middle attack. Layer 5, the session layer of the OSI model, is responsible for establishing, maintaining, and terminating virtual connections between 2 communication partners on the network. Problems with establishing a virtual private network, VPN, remote desktop protocol, RDP, or secure shell, SSH connections are all session layer problems. Layer 4, the transport layer, is responsible for error correction, flow control, and segmentation. The 2 protocols that function at this layer are the Transport Control Protocol, TCP, and the User Datagram Protocol, UDP. TCP is a connection-oriented protocol, which means that each device needs to acknowledge the other for the communication to occur, like a phone call. However, UDP is a connectionless protocol, which means the information is sent with no confirmation of receipt. It's kind of like an unanswered text message or sending a letter in the mail. TCP is slow but reliable, and UDP is fast but unreliable. TCP is used for important communications like displaying web pages or emails. UDP is used for time-sensitive communications like streaming video, streaming audio, and voice over Internet Protocol or VoIP calls. Both TCP and UDP use port numbers to keep track of the application layer protocol to which the message is intended. Firewalls, routers, and gateways use port numbers to permit or deny traffic by application. Some students may have had to configure their home routers with port forwarding to allow a game to play. Misconfigured devices may be blocking communications. Checking the configurations on these connectivity devices as well as on any host-based firewalls will help identify these problems. If the problem is still not identified or resolved, the technician should continue the troubleshooting process through the lower 3 layers. The top-down approach is one of the 3 approaches in the Open Systems Interconnection OSI model for troubleshooting. Steps to follow using this method were discussed in this micro-credential.